Alright, so we have seen how you can build your model. We have also discussed about the model summary. Now it is time to compile your model and you can start training your model. So after building this model, you need to compile your model. So during the compilation, you need to set the learning rate, you need to set the optimizer, you need to set there a loss function and also metrics on which your model will start, we will compare the loss function or the loss method. We have our model here. Then I do here model.compile. In this, I need to pass here the optimizer. So I pass here the optimizer, Adam optimizer. In that, I pass here the learning rate, which is 0.001. So this learning rate, there is no mathematical formula to select learning rate. This learning rate you can select by your experience or some random method. You just hit and trial method. Then we have here loss function. So loss function, we are gonna use here binary cross entropy. All right. So we use here binary cross entropy as a loss function. Thereafter, we are gonna use here a matrix, and in the matrix, I'm gonna use as the accuracy. So this accuracy will be used during the model evaluation, and then for loss function. So how your model will be evaluated during the back propagation, we are going to use here binary cross entropy. All right, let's go ahead and run it. The model compilation is done. Once model compilation is done, now it is time to do a model.fit. So you do here model.fit. It is time to train your model. So if you put cursor inside this fit, and press shift and the double tap, you see here details there. So you can pass their input training parameter, target output or the target variable, the batch size, epoch numbers or how many times your model will train there. All these parameters you can set there. So I'm going to pass here the train data, and thereafter I'm going to pass here the batch size equal to the 32. Again, there is no formula to select this batch size. By default, I'm just selecting it as the 32. Thereafter, you have here the epochs. Number of epochs are here 10. So I'm just going to train it 10 times or 10 iteration. Thereafter, I'm going to select here the class weight. So to select this class weight, there is two ways. Either you can set class weight equal to balanced, or you can set a class weight what we had calculated earlier. All right, so you can set any of these things. Let's go ahead and run it. It is going to start the training, but somehow there is something wrong somewhere. Okay, so seems like there is the problem with the class weight, because the class weight which we had got earlier, you see there, the class weight was not doing good. The reason is here for this class weight, we need to set it here. For 0, we want to set it like this. And then for 1, we need to set it something like this. So this class weight, we want to do it here. And that class weight, I'm just going to define it here one more time. All right. So thereafter, I'm just going to run it. Now it has keys there. So from that keys, it try to find out your class weight there. So it starts the accuracy from the 71 or around the 72%, and it starts increasing till the 80.91 there. So that's how you see there this accuracy has been increased. The one more thing I would like to tell you here, model.fit returns here some, the model training parameters or model training logs. You can store those into the history. So if you write it something like that, history equal to model.fit. So whatever the information is, whatever the information we are getting here during the training, you can store those information in the history there. All right. So the training we have got here, the accuracy around 82%. Now let's go ahead and plot our the history there. So we have here a history. This history is a callback method history. Inside the history and history, we will be having here a loss method and the accuracy there. And at the same time, I would like to do here validation so that we can find out that how the training accuracy and the validation accuracy is moving along. So there I can just set that the validation is split. A default validation is split. I'm just gonna set it here. Alright. A default validation is split. I'm gonna set here like the 0.1, which is the 10%. Now if I run it, it's gonna measure here the validation accuracy and the normal accuracy. Alright, so seems like the validation accuracy is a little less than the normal accuracy, or sometimes it is going up and down, but moreover it seems like it is doing its job there. After doing all these, now we are going to make here a plot there for this history, the training history. Alright, so this one you can plot using the matplotlib. So I write here hist is equal to the pd dot data frame. Alright, so in that I put here a history dot history, and then you can see this hist. We have loss accuracy for the training, and then we have a validation loss and the validation accuracy. You can simply call here hist.plot to plot these validation loss and the validation accuracy. So here we see the validation loss and the validation accuracy. It starts from the 0.8 till here. There is no difference. The reason is we have been running this multiple times. Alright, so we need to create our model. You can recreate your model from here. But if you recreate your model and you run your model summary, now these names just got changed here, because these when you run this multiple time, then these names actually get reassigned. That is why these names got changed. Other than these names, these parameter will be same there. There is no difference. Then I do all these process, and then if I do the training, then again it starts with the validation accuracy with the a little lesser. Alright, so I'm training it for 10 times, and thereafter I'll do this history plot. Now you can see that how it is increasing. After some iteration, probably 5-6 epoch, this seems like just the crossing to each other. So the moreover we can say that as of now, if we train it just for the 10 iteration, it seems like it is doing good enough. Alright, so this is all about in this lesson. Thanks a lot for watching this. I'll see you in next one.